Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is the BAC4000, now repaired. In depotting it, I did some minor damage to it, and I needed to depot it anyway to repair it, and I'll talk about all this stuff here. So, yeah, if you guys like my content, please like, subscribe, tell your friends about my videos. The more viewers I get, the better it is for me, because the only way I get to pay for stuff like this is through the monetization I get from YouTube. Otherwise, I pay for hardware to take it apart like this unless somebody's kind enough to give it to me. Alright, so the Bluetooth module, in depotting everything around here, its 4 little wires broke off. And so it was wrapped in Kapton, and I unwrapped it, and then I resoldered its 4 wires, and you can see the black silicone on there. Yeah, I don't want them to break again, so anyway, that's all silicone down, and then the little Bluetooth module is stuck down on a piece of double-sided foam tape. It's pretty much not going anywhere, and then of course all the glossy stuff all over everything is conformal. I figure that's kind of good to keep everything here from any possibility of water incursion. Anyway, yeah, did that on there. So that is now repaired, should be good to go. That's just a couple of little wires. Down here, so this little guy right there, yeah, that's 220 microhenry inductor, and yeah, I cannot believe that this one snapped off with the potting, but it did. So anyway, I scrounged one off of another board. The shell shape doesn't really matter. Anyway, yeah, I found another board, used my heat gun to unflow that one and then reflow it onto here, and so now that inductor is replaced. And once I had that all in place again, just to make sure this little bugger wouldn't get broken off again, I coated everything in conformal just to make sure it was glued down real good. This right here is a 7805 linear regulator. Uh-oh. What the heck happened here? Come on, camera. Yeah, there we go. So that's a 7805 linear regulator, producing 5 volts. Since both of these are over here by the I/O connectors, they are probably making 5 volts and 12 volts for those, you know, as an auxiliary power supply. I will show the other side of the board for this little guy after a while. But the other thing that I repaired was that pin right there on that connector. So this last pin right here was broken off, and so I stole one out of the connector from the BAC8000 and soldered it in place. So anyway, that connector is all repaired and good to go again. In extracting everything from the case, I caused some other damage. So you can see this set of legs right there, that's a MOSFET. I unsoldered the one that was there because I broke its legs. And then you can see another one right here. Same thing happened, I broke its legs. So I have replaced those MOSFETs with more AOT 290s that I have purchased from DigiKey or Mauser or whatever. So yeah, the board should be good to go now. Totally workable again, and raring to see some actual use. Alright, so right here you can see all these ceramic caps. And let me just paint across the board here. Yeah, you can see that there's quite a lot of them in there. And the BAC8000 is the same way. I definitely like seeing a lot of ceramic caps. Yeah, you can see more of them right here. So you'll notice that there's a larger one and a smaller one. I don't know what the values of these are, but essentially what you're doing here is filtering 2 different frequency ranges of high frequency noise. And you can see all across here that they're in pairs of a larger one and a smaller one. So they're kind of filtering 2 different frequency ranges of high frequency noise on the bus. And with so many of them like this, it's probably doing a pretty good job of it. I definitely like seeing them like this. And as you can see, here is the MOSFET legs right here. And all of those capacitors are all across that area right there. In other words, they're doing the best possible good they can, because they're right in between all the MOSFETs. So this right here, these 4, that's all one phase right there. And as you can see, there are 8 of those ceramic caps. 4 little ones, 4 big ones, for all of that high frequency filtering for that phase. So that's pretty cool. I definitely like seeing that kind of thing. When you just see, like, this is the edge of the board over here, when you just see like 5 or 4 or whatever of them down at that edge, well, that's not really doing a whole lot of good. You really need to have the ceramic capacitors at the MOSFETs to do the best good. Otherwise, if they're just down here in this one edge or something and they're nowhere else, you know, like say the KO Moto controllers are that way. What else do I run that way? eBeamX, I think, does it that way. Yeah, you're basically not really doing a very good job of filtering high-frequency noise. You're only doing it right there locally at that spot, but you're not doing it like right in between the MOSFETs where it's best. And so yeah, you're getting some noise filtering down at one end of the board, but not on the other. Yeah, it's much better if they are right at the MOSFETs. You can see these little guys right here. So those are a 2063 op amp, and give me a second, I've got those little guys looked up. There we go. So that is a 2 microamp supply current zero drift op amp. So some signal on this board needs to be boosted, and you need one for the low side and one for the high side. So don't really know more about them than that. I could figure out all this little bit of electronics around here and then tell you like whether it's making gain or how much gain it is, things like that. But yeah, you don't really need to know that stuff. All right, so right here, that little guy. So that is an Allegro Micro current sensor, and it's an ACS 770, and it's a 150 amp version. It's not really showing up on camera all that well. Yeah, there we go. Kind of see the part number on there. But anyway, yeah, these are rated for 150 amps. Essentially how this works is, you know, here is the phase bus side of it, and the phase bus is essentially on the other side of the board right here. So current comes in here, and it comes out here, and then it heads over to one of the studs over here for the actual current path. Anyway, yeah, this is an actual current path in here, and this one is rated for 150 amps. So you do have some losses when you use this kind of a current sensor as compared to, say, like a current loop like that's on the BAC4000. You know, Far Driver uses them, Teleria, KO Moto, eBeamX, they're all using those current loops. Yeah, you have different advantages for each one. Anyway, you are still measuring a magnetic field that's created in this loop right here of copper. And right there where those 3 legs are, there is a little linear hull in here that's placed right up next to that copper, and you're detecting the magnetic field that's in the copper loop. So it does very much similar functionality to a current loop type sensor, an inductive sensor. It's just doing a little bit different, and it's actually part of the current path. So a little bit different way, it still works well enough. Alright, so what else do I want to show you on the top of the board here? I think I've shown you all my repairs. There's not a whole lot to see here without looking at the BAC8000. So I'm going to flip this over and show the last couple other parts here, and then we'll use that from then on. Alright, so this right here is the buck chip, and you saw the inductor I had to replace for that on the other side of the board. So this is a little DC to DC converter, and my assumption is that it's making like 12 volts maybe, or 5 volts, but right next to it, this little chip, sorry I put conformal all over it, but that says, can't probably see it, 7805, pretty sure that's what it says on there, which would make that a 5 volt linear regulator. Let's see if I can't see it with a loop. Yeah, part number is pretty obscured under the conformal, so I can't really see the number. That's what I remember seeing on the thing before it coded it. Yeah, I can see 7805 on it. So anyway, yeah, that's a little 5 volt linear regulator right there. And so probably we have 12 volts here and 5 volts here, and that's probably for all of these connectors right here. You know, for external stuff. It's probably not really doing much on board. The logic board, we won't look at that on here. You know, I've obviously coated everything in conformal just to secure it and waterproof it and protect it. Anyway, yeah, so I was talking about that little buck chip right there. I have not been able to find that 9CP237J. I found something similar to it, That's also by the same company. Hold on a second, let me find that little guy. There it is. So you can see the logo up there, and that's a Linear Technology logo on there. And whenever I Google for this part, Google would always bring me over to an LTC 3824. Problem is, though, is the pinout doesn't match. So this is not an LTC 3824 because this only has 8 pins on it, and the 3824 has 10 pins. So I don't know what this is. If somebody else knows what part this is, feel free to leave that in the comments below. And yeah, we can just go from there, and I can just add that as an addendum. Not really much else to see here. A couple little transistors, some small capacitors and resistors, and that's about it. On the bottom side of the board, yeah, not really much to see. You can see the phase buses, though. So you can see all this copper across here. Yeah, so there's like a big square, essentially. And that passes underneath all the MOSFETs in here. Let me flip this around the other way. There we go. Oop. Yeah, and then you can see how it comes out the other side. So this is all part of it as well. Oops, I'm on the wrong phase. There we go. That one. Now we're looking at the right one. So anyway, yes, you can see all this is all part of it, and you can see those 3 little spots I mentioned before. So they kind of provide a current choke point. And then here is the 2 legs on the ACS 770 current sensor, providing the 4th current path. So you essentially create a current divider with these 3 little thin spots, and then across the ACS current sensor, since it's only rated for 150 amps and not like the 400 phase amps that this 24 FET controller can handle. So yeah, that's how they pulled it off, and you can see the same thing happening. Oh, that one doesn't have it. There we go. And you can see the same thing happening in that 3rd phase. Yeah, this middle one here, you just get a single solid piece of copper tracing on here going right over to the phase terminal. Anyway, this is enough for the job. And it makes the controller a lot less expensive. If you don't have any copper reinforcing, just use a big piece of flat copper on the circuit board, and you pretty well got it covered. And that's what ASI's solution is. And of course, with everything here having a zillion vias in it, you also have other reinforcing inside the board. So like those are battery plus and minus right there and there. And those all have a copper plane inside the board. And yeah, like you can see a few of them. A few of the vias right there. Kind of peeking out from underneath the solder. Alright, well, that's pretty much everything to look at here. Let me grab the BAC4000 for everything else. Okay. So, yeah, we're going to do components this time, which I didn't do last time. So here you've got a 7805 linear regulator, and there is one peeking out underneath the BAC4000 as well in that same position. This right here, this fan 7388, that is the MOSFET driver. I said it was like a MUX or something like that on the BAC8000. Yeah, well, I wasn't doing parts lookup at the time, and now I am. So let's look at that little guy. Give me just a second. I have to find it here. There it is. So that's a fan 7388, and it's a 3 half-bridge gate drive IC. They're good up to whatever it is, 600 volts I think it is. Yeah, 600 volts. And they can deliver 600 milliamps source or sink. So that's going to be enough to drive 4 or 6 MOSFETs. Like the BAC8000's got this exact same chip on it. That's going to be enough to drive those MOSFETs. And then right over here, that little pit chip, that LM2901, that's just an op amp. And wherever it is, let me find it here. So ASI likes using a lot of analog devices, a lot of Western parts. I definitely like seeing all of that. There it is. So yeah, that's just a quad differential op amp package. Yeah, I don't know exactly what it's having to amplify or make smaller signals bigger, but yeah, that's essentially all that one's doing. It's just a little operational amplifier package. Anyway, not a lot else to look at here. Yeah, I guess you can see those. So that's those two little 0 point op amps, exactly the same on here as it is on the BAC4000. And obviously this is the BAC8000 board now, because now we can see underneath all of this stuff. All right, there's not much else to see here. We've already looked at this before, so I'm just going to move on to the logic board. And here is that. Okay, so oh, that looked better the other way. You can see the part numbers. There we go. Do it sideways. Yeah, so you can see the TMS 320. That's your CPU. This part right here says 1043 on it. That is a CAN chip. And let's see here. Where is that one? Yeah, there it is. So that's actually a TI part. TCAN 1043, and it's a low power fault protected CAN transceiver. So the actual CAN protocol is done in the TMS 320, and then this is just a transceiver chip. This is an LM2901. That's just a little op amp package, and as you can see again, it's got an onsemi logo on it, and that's just a quad differential comparator. Same thing as like what you saw on the main board. Nothing real special about that. Yeah, Texas Instruments makes that part. onsemi does. Probably 3 or 4 other manufacturers do. Fairly common part. Yeah, right here you can see a 7805 linear regulator. So producing 5 volts on the board. Yeah, right there you can see a little isolation transformer. And so that's all CAN bus related components right there. Yeah, this is a common way to isolate the input to the output of something, so that like high voltage or high frequency spikes, things like that, can't travel in. Just use a little isolation transformer for things like that. Let's see, anything else to see? Oh yeah. So right there, that little thing, that is a little 3 volt linear regulator, which is what the TMS 320 needs to run. So these other components here, they need 5 volts, and that needs 3 volts. And of course, on the other side of the board here, you have a buck chip, or not a buck chip, but the buck chip is right next to it, that little guy right there. So that's taking probably battery voltage and converting it down to say like 12 volts perhaps, because probably like all the gate electronics need 12 volts. But yeah, you've got a little DC to DC converter here as well. And that's pretty much everything there is to see on these controllers. So yeah, looked up the parts this time, and I have been doing that ever since. So hope that helps some folks out. And that's the BAC4000, for all intents and purposes, using BAC8000 parts in the process.